So this is chapter 1, some of the chemical foundations that we are going to need badly this year. We are asking, working with the significant figures addition and subtraction. Part E, we have a mass of a crucible, 8 grams. Mass of the crucible plus sample is 12.4 grams, and mass of the sample by subtraction is 4.4 grams. But how many significant figures should be there? The rule says that in addition or subtraction, the answer should be reported to the least number of decimal places. So there is one decimal place only here in the mass of crucible, 12.4, and 2 here, so I will use 1, so the answer should be 1 decimal place, 4.4. Another question which is similar, mass of the empty flask is 121.01, mass of the flask filled with water is 321, and density of water is 1 gram, volume of flask is requested. The volume of flask is found by subtraction. So 321 minus 121 is 200 grams. And if you want to find the volume, just divide the mass. The density is 1. So if the mass is 200 grams, so the volume is 200 milliliters. Now we have the flask filled with carbon dioxide, 123.2 grams. And we said that this is 200 grams, so volume is equal to 200 divided by 1, so 200 ml. For ratio, the answer is reported to the least number of significant figures. So ratio is, or the division is, this number of significant figures. I have here 2 significant figures, 3 significant figures, so the answer should be 200 dot. The mass of carbon dioxide is equal to subtraction, like we said from the last time. So it is the subtraction of 123.2 minus 121.01, and we said there is 1 decimal place here, so the answer should be 1 decimal place also. So 2.2 grams, only 1 decimal place. The number of moles of carbon dioxide is found by mass over the molar mass. So let's try to find some significant figures. Here I have scientific notation. Scientific notation, I take the 3 numbers here, so 3 significant figures. I have here 18304 significant figures. The zeros on the left are never counted as significant, but the ones on the right, as long as there is a decimal point, so there would be counted. So 4 significant figures. Here I have 4 also. Here I have 1, because this one is counted, the 7. The other zeros on the left are never counted, so 1 significant figure. Here I have 1, 2, 3, 4, 5, 6, 7 significant figures. If I don't have any dots, so 1 significant figure, the zeros are not counted. But here there is a dot, decimal place, so there are 3 significant figures. Now I have HCl is equal to 0.01 molar, pH is equal to what? So pH is equal to negative log. We know that negative log of 0.01 is 2, but how many decimal places I will put? The number of decimal places is equal to the number of significant figures in the concentration. So the concentration has 2 significant figures, the 1 and the 0. So there will be 2 decimal places here also. I have OH minus equal to what if the pOH is equal to 13? So I put 10 to the power of negative the pOH, which is 10 to the power of negative 13. So 1 multiplied 10 to the power of negative 13. Here I have 1 decimal place, so such significant figure should be 1 only. So it should be 1 only. It should be only 1. What is precision and what's accuracy? Accuracy refers to the agreement of particle with the true value. The true value is here in the middle, so the answer is around here. This is accurate. Precise, that the number of results are close to each other, but they are not close to the accuracy, to the true value. So the degree of agreement among several measurements of the same quantity. I can have 2 types of errors. I can have random error, like my answer should be on the line. Sometimes the answers come out of the line up or down, so randomly. If it is high or low, then the result, so it is random error. Systematic error, this is every time I'm getting the answer, it's on the same side, either high or low. This means that it's not a random error, it is something that I'm doing wrong. So my process or my method, there is something I'm doing wrong. That's why the answer is coming wrong every time. In which of the following are the zeros not significant? So 0 here is significant. Yes. or not. This is a leading zero on the left side. So leading zero is not significant. Anything on the left is never significant. Anything zero on the left, never significant. Here it is significant because there is a decimal point. Here three significant figures, so zero in the middle, capture is in the middle, so significant. Zero here on the right, but no dot. So trailing zero is not significant. What are the exact numbers that were not obtained using measuring devices? I have 12 students. 2 in the 2 pi, for example, 1 kilometer. This is not something that I measured. I cannot say 12.1 student. This is an exact number. It has infinite number of significant figures. I have unit conversion here. Let's remember together the unit conversion using the conversion units. Some temperature conversion. If I want to change from the Celsius into a Kelvin, you have to add 273. If you want to change back to the Celsius, you have to subtract 273. So 127 Celsius is equal to 400 Kelvin. Calculate the density given mass and volume. So density equal to mass over volume. Some notes about the properties of the solids, the liquids, and the gases, the volume, the shape, the density, the structure, the motion, and compressibility. And that's the end of this part, and see you in the next video.